Hi together. My name is Robert Lotter. I'm working as a lead consultant for Devo Team A Cloud Germany. And today I want to present to you a customer success story where we migrated a system from on-prem to AWS, leveraging serverless technologies. And this actually increased the cost efficiency and high availability significantly. So first, a few words to myself. So I have 7 years of experience in IT business so far, where 6 of these years I was working for Devo Team. I started here as a Java backend developer, and still I'm working as a backend developer sometimes, but I would consider myself as a DevOps engineer and an AWS architect. So I would sell it. My main skills are developing microservices, creating CI/CD pipelines, migrating to AWS, and especially using serverless technologies here. So this is the little agenda for my presentation. In the first chapter, I want to talk a little bit about the system itself. I can't mention the customer or go into detail when it comes to the business logic, but I just want to give you a brief overview about the components. In the second chapter, I want to talk about the motivation. So how did the old setup look like? What problems did we face? And especially, how did we solve them? In the third chapter, I want to show you the architecture and go into detail on some components. And also, I want to talk about the responsibilities in this project. In the fourth chapter, I want to talk about the achievements that we reach. So be curious. And at the end, you have the chance to ask me any questions. All right. So first of all, let's talk about the system. So what's the purpose of the system and how does it look like? So the main purpose of the system is to provide some backend functionality for calculating, a response based on a specific input and based on master data. So this is very in general. This functionality is provided by a core service, which is written in Go and provides an HTTP endpoint. The second service or the second component is our sync service, which synchronizes data from an on-premise data center to our local database or to the system database. Also, we have some simulation services, which can, as the name says, simulate the core logic so that the customer knows if he in future sends some requests, will they succeed or not, basically. Additionally to that, we have a GUI application, which is written in Angular with a backend written in Go. And the purpose of the GUI application is to have the ability for some configuration, for viewing logs, for doing some test requests, and so on. And at last, the database, which is a Postgres database and where we store our master data and some configuration, and also the requests, the responses, and so on. All right. So let's talk about the motivation. So in the first step, I want to show you how the previous setup looked like. So all these applications were running in an on-premise Kubernetes cluster. For redundancy purposes, we created we duplicated these clusters into 2 different data centers for each environment, so for prod and int environment, so that we can achieve a really high availability because the workload is really business critical and should never be down. We had our CI/CD pipelines running on Jenkins. We stored the Docker images in the customer registry, and our database was set up on on-premise virtual machines and was maintained and set up by us, the database itself. So actually, this is a really good setup, and it was running for, I think, 2 or 3 years on production mode, in live mode, and we didn't have a lot of problems, but actually we had some problems. So what were these problems? So first of all, we had really high cost because a lot of these applications were running in idle mode, even though they were not used for hours or for days or sometimes even for weeks. And as already mentioned, we had a lot of redundancy. So we had a similar cluster in 2 data centers just for high availability, which doubled the cost. Also, we had possibly long builds since the Jenkins server was used by several projects, by several users, and this caused some problems as well. Also, the Docker registry had a lot of downtimes, which didn't affect the live system, but could, well, make some problems when we had to deploy our services. What actually was a problem sometimes was the database, because the database storage didn't scale automatically. And actually we had an incident where the database storage went full and we had to do some manual stuff there. Also, when the database servers were patched, we had some possible problems. And which is also not very nice is that we had to set up and maintain the database cluster on our own, which is, well, really complex. So how did we solve all these problems? And of course, the answer is we moved to AWS. And here's a little overview which components solved these problems. So, well, using Lambda or serverless technologies, of course, made our problem with the idle apps completely resolved. And also we didn't need to provide redundant infrastructure there. Yeah, Code Pipeline also solved our problems because it's also a completely serverless technology using Code Pipeline and Code Build. And we didn't have to use Docker images anymore since we use Lambda. And also RDS solved all of our database problems. So now I want to give you a little overview over the architecture. It's on very high level. So and also some components are not visible here. And of course, we are using VPC, subnets, security groups, and so on. But this is not something I want to show here. I really just want to show what technologies did we use to improve our system. So as you can see, we have a web application firewall, which is completely serverless, API gateway, which is completely serverless. And also all of our backend services are implemented as Lambda functions. So we actually just pay what we use and had no idle applications at all. And here, CloudFront, ALB, S3, also completely serverless technologies are used for our GUI application. So the only component that is not serverless was our RDS, but I will come to that in a minute. So here, some details. So, well, all of our backend services were moved to Lambda. So as already mentioned, we have no idle times there. And also we had complete redundancy because we could provide different availability zones for our Lambda functions. So we are not affected from downtimes there. For our CI/CD pipelines, we use Code Pipeline and Code Build, which is also completely serverless and just runs on demand, because we are using these pipelines maybe once a day, maybe once a week. So no need to have a dedicated server for that. Also, we created a lot of alarms with CloudWatch. For example, if API gateway returns a lot of 4xx or 5xx errors, or if the database is under pressure, or if the pipeline fails, we created CloudWatch alarms that are sending their alarms to SNS, which is a simple notification service, also a completely serverless technology. And then emails were generated to specific target groups. Our GUI application, as already mentioned, was provided with CloudFront, which is also a completely serverless service where you just pay what you use, S3 and ALB. And as already mentioned, the database was the only not serverless component. So This is true for int and prod environment. We have a provisioned Aurora RDS there because we have a pretty constant load on our core service, so that a serverless database would be more expensive than the provisioned one. For dev and test environment, we actually have an Aurora serverless database, which is really awesome because it can go down to 0 capacity units, which means that this is more or less shut down and doesn't create any cost, because on dev and test environment, we don't have any requests at all per day, maybe 1 or 2, sometimes 10 or something like this. And then the database starts on demand. The first request, of course, needs a little bit longer, a few seconds, but it's completely fine on our test environment. All right. Well, maybe some words to the responsibilities. So what did we actually do? So we created all the architecture for the whole system. We provided the CI/CD pipelines. We set up the CloudWatch alarms. We developed these applications. I mean, we developed these applications even before we moved to AWS, but we had to make some adaptations because when you use Lambda functions, you need to adapt your code a little bit. And we set up the whole infrastructure with Terraform. Or not the whole infrastructure, because when we go to the right side, we see the customer provided the AWS accounts, but also set up some basic infrastructure like VPC, routing tables, transit gateway, hosted zones, which was well shared with also with our other projects. And we were using an Elasticsearch and Kibana for monitoring, also from customer, and same for the GitHub. All right, so now I think the most interesting chapter. So what did we actually achieve? So as already written in the title, we were increasing the high availability and the cost efficiency significantly, but also we had some positive side effects, for example, on scalability, maintenance, and even on sustainability. So let's have a look at all of these points. So first of all, high availability. So the system is now live for, I think, nearly 1 year now, and we didn't have even 1 second of downtime so far, which means we have an availability of 100%. And I think that is really great. The second thing, cost reduction. We actually decreased the operational cost by 80%, which is a lot. And I cannot give you the exact numbers, but what I can give you is one example. And I think this is hilarious. We pay $20 per month for all our Lambda functions combined on all environments. So this is our complete backend logic. And I think $20 is like nothing, which is really great. Also, the scalability is affected because we can run 1,000 concurrent executions on our Lambda functions. Of course, we have to limit them based on the service, but that's our hard limit or our soft limit so far. We don't have any problems with the database anymore, since it can automatically scale up to 128 terabyte. I mean, we will never use this amount, but it would be possible. And also, if the DB performance is affected, we are able to scale here in minutes. So I mean, database RDS serverless does this automatically, but even for the provisioned one, we are able to increase RAM and CPU in minutes, which is really great, I think. Also, a positive effect was that we have less maintenance. So we have absolutely no more servers to maintain. And even the database is completely managed by AWS, and we don't have to do anything. And the last point, which I think is really great, is sustainability. So we reduce the CO2 footprint of our system by using serverless technologies, because we don't run any applications in idle mode, so we don't waste energy. And also AWS focuses on really provide their data centers with more green energy, more and more. So I think this is also a really great point. All right, so that was it for now. If you have any questions, feel free to ask, and thank you for your attendance.